To design purlins from our floor framing plan, these are the purlins in this roof framing that we would be designing. We will design purlins in the area where net wind pressure is higher. There is no need for us to design all these purlins here one by one. We chose 2 locations only. Or in our diagram here, we can design purlins located in the overhang here. The wind intensity is quite intense here, especially the suction. So we know if members in this area pass the strength design calculation, then the rest of the members would also pass the design requirement. Then we will also design purlins in Zone 1 region, here in the middle. So in the overhang, we chose this portion here, and in Zone 2, this portion here. Now let us open STAAD. And let's model first the purlins in the overhang location. Click New. Let's say purlins design. And let us save this in desktop. Click Create. This node 1 is our starting node with 0, 0, 0 coordinates. Just type 0 here, then hit Enter on the keyboard. So we see here in a single snap, the columns are filled with triple 0 as coordinates of this node. Using node cursor, select the node, then go to Geometry, Translational Repeat. Here the direction is the X direction. Number of steps, meaning we would copy the nodes by a number of times. So from this framing here, these are the purlins that we are designing. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 purlins. So we need 9 more nodes. So number of steps, 9. And the distance of every node is 1.361, 2.32, 2.33, 2.33, 2.33, 2.34, 2.33, 2.32, 1.361. Then click Link Steps. Then click OK. Now let's go to Properties and define the section of these purlins. Let us use User Table here. Click this, and in the drop-down menu, select Channel, then click OK. Click Add to open channel profile. This is the section. Let us define first the name of our section. Let's say C channel. Then the depth is 0.1 meter. Thickness of plants is 0.002 meter. Wide plants is 0.05 meter. Thickness of web is 0.002 meter. Then click Calculate. After that, click OK. Then close. To add that section here, click User Table again, then highlight C channel. Select Material in the drop-down menu. Choose A36 as the material strength, then click Add, then close. To apply this to our model, highlight the section, then in the model, select all the purlins. Click Assign to selected beams, then click Assign. Now let's go to Support here. Click Select Enforce Back. Release moment about Y and moment about G. Highlight this, then select all the nodes, then click Assign to selected nodes, then click Assign. Let's go to Loading. Expand this one here. Now, this area, we don't need as of this time because we are working on components and cladding, so we will not be assigning any earthquake forces. Let's go to Load Cases Details, then click Add. Select first Dead in the drop-down menu for dead load. then write here DL for dead load, then click add. Next, select live for live load, write here LL for live load, then add. Then roof live, type RL, then add. Then wind, then type WL1 for direct pressure, click add. Then type WL2 for suction, then click add, then click close. Click DL, then add. Self with load, Y, -1, add. Let us apply this, click self with Y, click assign to view, then click assign. Click DL again to add more dead load. Click add, then in the left side, click member load. I use weight of Spanish roofing, which is 0.91 kN per square meter. To convert this into a uniform line load, multiply it by PURLINS spacing of 0.75 meter. Now it becomes 0.68 kN per meter as uniform load in PURLINS. So type -0.68, then click add. Let's apply this immediately. Click the load to highlight, select PURLINS in the model, click assign to selected beams, then click assign. Click LL to highlight here, then click add. Click member load. I assume live load of 1 kilopascal multiplied by PURLINS spacing equal to 0.75 meter, which now equal to 0.75 kN per meter uniform load. And let's apply this. Type -0.75, then click add. Highlight this load, select all the PURLINS in the model, then click assign to selected beams, then click assign. Roof live load is just same for live load. Click RL to highlight here, then click add. Click member load. Roof live load is 1 kilopascal, and I got this from table 205-3 in NSCP. From here, our roofing slope falls here with tributary 0 to 20. So we select 1 kilopascal as our roof live load, multiplied by PURLINS spacing equal to 0.75 meter to convert it to uniform load, which now equal to -0.75 kN per meter. And let's apply this immediately. Type -0.75, then click add. Highlight the load, select all the PURLINS in the model, then click assign to selected beams, then click assign. Click WL1, then click add. Again, member load. Our wind load 1 is a direct pressure directed downward of 0.89 kN per meter from our table here in Excel. So it is -0.89. Local Y, click add. Let us apply this, highlight the load, then select all the members, click assign to selected beams, then click assign. Now for WL2, highlight, then click add. Click member load. This WL2 is the suction. So in STAAD, it is directed upward. So in our table, the load is -3.14 kN meter. The meaning of negative sign here means suction. So type type 3.14 local Y, then click add. Let us apply this. Highlight the load, select all the members in the model, click assign to selected beams, then click assign. Now we will add load combinations. To add load combination, click load case details and then click add. Then in the left side, click define load combinations. And in our Excel file, Our first load combination is this one. This is from NSCP section 203.3.1. Equation 203-2. So let us copy this to STAAD. Paste it here. Then dead load, live load, rope live load. These three items from here, bring this to the right and replace the default factor with this factor here. Dead load 1.2, live load 1.6, and rope live load 0.5. Then click add. Next, this one, and this is from equation 203-3. Next, this one, this is from equation 203-4. Copy this, paste here. There are 4 items now: dead load, live load, rope live load, and wind load 1. Here, select the 4 and bring them to the right. 1.2, 0.5, 0.5, then 1. Then click add. Next, this one, this is from equation 203-4 of NSCP section 203.3.1. Dead load, live load, rope live load, wind load 2, 1.2, 0.5, 0.5, and 1. Click add. Next, this one from equation 203-6 of NSCP section 203.3.1. Dead load, wind load 1, bring to the right. Replace 1 with 0.9, then click add. Next, this one, still from equation 203-6 again. Copy this, paste it here. Dead load, wind load 2, bring to the right. Replace 1 with 0.9, then click add. Then click close. Then from here, go to analysis tab. Click it. Click analysis commands here. Now there are a lot of items to choose here, but this time we need to choose perform analysis. And it is here, it is already selected. Just click no print at this point of time. Then click add. Next, go to post analysis command to add load list. Click here define commands. Click load list. Then we select here the load combinations we want STAAD to use in the strength design calculation. Just bring to the right, then click add. Now let us go to design. Click design, then in the drop down menu, select the code EIAC 360-16. Then down below, click define parameters. So here, we are going to select what we want here. Here, select FYLD, then replace the value with 248,275 kilopascal. Then next, let us select this method. Then in this method, select LRFD. Then click add. So nothing else here. Click close. Highlight FYLD, then click Assign to View. Click Commands to the right. Click Check Code, click Assign. Click Members Take Off, click Assign. Click Take Off, click Assign. That's it. Then click Close. Click Run Analysis to start the calculation. Zero errors, zero warning. Click Done. Now double click any of the members. Now the result is down here. Pass. So this member is okay. To know which members failed in the design, go to Select, Attributes, then Property Name. Then click Failed Beams. It says no failed beams for the detailed design calculation. So all the members are okay. But wait a minute. In actual construction, the purlins are laid inclined 15 degrees with respect to the horizontal. Same with that of truss top chord. If we rotate this purlins by negative 15 degrees, the loads which we applied vertically and which is currently directed downward will create components along J direction. So for example, if we check the deflection of this member, let us say this member here, and let us say we use dead load only. The deflection is negative 0.414 millimeter in Y direction. That is in Y direction, local Y. And in J direction, the deflection is 0. Because in this time, the purlins is laid 0 degrees with respect to horizontal. Now let us rotate these members and check afterwards what would happen then to the member. Then analyze again. And now let us check the deflection along J direction. Now before it was 0. Let us check. So as we see, the deflection is already negative 0.734 millimeter in J direction. So let us check failed members if there are. Yes. Now 7 members failed in the design. Now how to resolve this? To resolve this, in actual, we are going to provide sagrad to resist any movement in J direction. Let us add support. Then click Enforce Bath again. Check except FZ. Then click Add. Go to Geometry. Click Insert Node. Analyze again. Check the failed beams. So we see all beams now are okay when it comes to strength design. Now let us model and design the purlins in zone 1. In this area, the total length of this purlins is 1.1782 meters. So in here, let us call this purlins design 2. And let us save this in the desktop. Then click create. Just type here 0, click enter. Now in this drawing, we will take note how many spans here. 1, 2, 3, 4, 5. So we have 5 spans of purlins. So type here 5. And the distance of every purlins here is 2.33, 2.33. We have here 2.33. Then here 2.34. Then last is 2.33. Then click link steps. Then click OK. Our wind load 1 is negative 0.89, same that of our previous model in purlins. Now for our wind load 2, we have 2.32 kN per meter in zone 2 and 1.4 kN per meter in zone 1. So 2.32 kN per meter, this is 1 meter. Our next video is to model and design the trusses. Thanks for watching. If you are new to our channel, please don't forget to hit the subscribe button for you to always be updated. And if you learned something in this video, please give some thumbs up. And don't forget to share this to your friends and relatives. Thanks for watching and see you next time. Bye!